Welcome to the Crazy Hat Chemist. So another video here on acids, bases, and titrations. So let's get moving. Bam! So today we're talking about buffer calculation number 3. Okay, so what is the pH of a buffer solution composed of 0.045 molar ammonia, that's NH3, with 0.050 molar ammonium chloride, that's NH4Cl. The Kb of ammonia is 1.8 times 10 to the negative 5. All right, so we do have concentrations of conjugate pairs, so that's why we're going to be using the Henderson-Hasselbalch equation, which is the pH is equal to the pKa plus the log of the conjugate base of the conjugate acid. So ammonia, that is the conjugate base. Okay, that is certainly the conjugate base. Ammonium chloride is, of course, the conjugate acid. It is actually a salt, but it's the ammonium ion, which is the conjugate acid of ammonia, which is the conjugate base. Now, I do have a Kb value, okay, so I'm going to take that Kb value and I need to convert that into a Ka. So I'm going to use this equation here, and that's the Kw, that's the constant for the dissociation constant for the water, or the self-auto-ionization constant for water, that is a constant, is equal to the Ka times the Kb. So I'm going to solve for the Ka. I'm going to substitute into this equation the Kb and the Kw. I've done that right here. The Kw is equal to 1.0 times 10 to the negative 14. That's equal to Ka times the Kb, 1.8 times 10 to the negative 5. So divide both sides by 1.8 times 10 to the negative 5, and I'm going to get the Ka. The Ka is equal to 5.6 times 10 to the negative 10. I'm going to substitute that into the Henderson-Hasselbalch equation right in here for the Ka. I'm going to take the negative log of that. So now let's plug in all these values here into the Henderson-Hasselbalch equation. So I got pH is equal to the negative log of 5.6 times 10 negative 10 plus the log of 0.045 divided by 0.050. Okay, do a little bit of simplification with that log and that division problem to get my quotient and the log. I got a pH is equal to 9.25, that's the pKa of the Ka, plus negative 0.0458, that is the log of that conjugate base over conjugate acid. I'm going to get this value right here, which is the pH is equal to 9.21. This should make sense for you because this is a base, excuse me, so it should have a pH that is greater than 7. Furthermore, I want to emphasize another fact here, and that is that the pH is greatly dictated by the Ka. You should see on the previous step, right before the pH is equal to 9.21, you got 9.25. That is the pKa. That is so very close to what the pH is. Okay, remember the conjugate acid-base pair is just doing a slight adjustment to the pKa to give you that pH of 9.21. And that again is a base, whereas the previous problem, we had an acid, and that's why that pH was less than 7. I am the Crazy Hat Chemist, and of course that's why I've got myself a crazy hat, and I got this from one of my students. Again, don't forget about getting the stickers, okay? Or maybe even a t-shirt. Yeah, look at that. If you love my videos, give me a thumbs up, subscribe to my YouTube channel, and please pass it on to all your cool chemistry friends. And I'll see you next time. Bye for now.